Hey guys, welcome back. Today is day 50 and we're going to be talking about modeling polynomials. This is actually a very easy lesson. It's just kind of getting you ready in case you ever see some kind of polynomials that are modeled and you're confused by it. We may see something like this on the SOL, so I just want to make sure you've been exposed to it. So a lot of times we do modeling polynomials with algebra tiles. They're little plastic squares, but we don't have access to them this year, so we're just going to kind of talk hypothetically about what it would look like. So if you had, in this particular example, the shaded tiles we have represent positive tiles, and the non-shaded tiles represent negative tiles. So if I was looking at this, the big square here would mean x squared, the little rectangle would be x, and then the little square would just be a constant. Okay, so, and that would be the positive versus the negative. All right, so in order to use an algebra tile to model it, if I have three positive x squared tiles, this would be an x squared tile, x squared, and x squared. So that's how we get the 3x squared. Okay, these would be two negative tiles, so that's how we would have negative 2x, and then we have 5 positive tiles. Okay, so this is what the model would look like. We have 3x squareds, negative 2x plus 5. Okay, so here's an example of our x squared. This one is x squared. 3x, so we have 3 x's, they're positive, and then we've got negative 6 ones. Okay, so that's how we get x squared plus 3x minus 6. All right, here we've got b squared, doesn't matter what the variable is, so this is a b squared and a b squared, so we have 2b squared. This is a negative b, and then this would be plus 4. Okay, so that's how we get 2b squared minus b plus 4. All right, d, 5a, we've just got 1, 2, 3, 4, 5, and then minus 1, minus 1, minus 1. Okay, those are all, that's how we would get 5a minus 3. And remember, any variable can be used instead of x. Okay, so if we wanted to model the following, we got negative 5x squared. So if you recall, our negatives were just not striped. So let's get to that page here. So it would look like this: 5x squared, 1, 2, 3, 4, 5. So there's our negative 5x squared. Okay, these should all hypothetically be the same size. Okay. Minus 2x means we have two rectangles, and then plus 5. So we're going to make 5 little ones that are striped. Okay. Our next example, negative 2x squared, we're going to have two big squares, and then we have 3 x's, so we're going to make 1, 2, 3. And these are all solid, so they're going to have the dashes through them. And then a negative 1. So it's going to be just a little square. So that would be negative 2x squared plus 3x minus 1. All right, now if we went backwards and we looked at the polynomial expression, and then we had to write the polynomial for each of the diagrams below. Okay, so looking at this one, this would be x squared minus 2x. Okay, because this is a negative x, this is a negative x. This one would be negative x, negative x, negative x, so negative 3x squared. Okay, plus 1. Okay, and this one would be 2x squared plus 4x. And then this is going to be minus 1, 1, 2, 3. Okay, so that shouldn't be too hard. All right. The other thing I wanted to get into is this week our Algebra Weekly SOL practice. Okay, so as part of the preparation for the upcoming SOL, you will complete 10 online practice questions from Jefferson Lab website each week, and that can be found in Q4, and it's JLabs. Okay, JLabs in the Schoology file. This file will be there. So this kind of goes through and explains how to bring up your JLab and how to score it, how it's going to be scored. Okay, so go through that. If you have any questions, let me know. So this lesson shouldn't have been too hard. Bye.